Okay, my people, let's do this. Let's talk about the basics and the differences between these three chi-square tests in here. All right, so what's going on first? The first thing you should know is all three of these tests have nothing to do with quantitative variables. All of them are going to be dealing with categorical variables. The first one is called the goodness of fit test. And what is a goodness of fit test? It's really a fight between two things. You're going to take some sort of sample that has a distribution from your categorical variable, and you're kind of comparing it with some established prior known of what it's supposed to be. So that's where we get the name fit. How good is it fitting? Your data versus what it's supposed to be. And keep in mind, this is a categorical variable. So that's the goodness of fit test. So we say it's a distribution of one categorical variable in one population. The other two tests here are different. There are some similarities, and they are different. So these two tests are called tests for homogeneity and the test for independence. So a little funny story. For many years, I think I was mispronouncing this word right here. Then I started asking around. No one would pronounce it the same exact way. So I found this link in here. Even in this link, they have two different particular pronunciations of this word in here. There's a UK version, which sounds like this.
Homogeneity, homogeneity, homogeneity.
And then there's the US version.
Homogeneity, homogeneity, homogeneity.
Yeah, it's always been a little tongue twister for me. So, yeah, homogeneity right there. That is a distribution of one categorical variable across two or more populations. So I made this little diagram over here that's outlining what? Well, we have two groups in this case, and we have one particular variable, and we're trying to see if there's a difference in this categorical variable across these two groups. But it doesn't even have to be two groups. It could be two or more groups. And I know what some of you are thinking right now, Mr. Keys, that sounds like chapter 10, a two sample z-test. And I know it does feel like that, but it's more complicated for a few reasons. One reason is it's not necessarily two groups. It could be two or more groups. And the subtle difference between chapter 10 and this particular test for homogeneity is there are several different choices of these categorical variables. Like this one has 6 choices, for example. So in chapter 10, it was really a proportion of, hey, did it hit or did it not hit? All right. So in this one, we are trying to see across all of these different choices within the categorical variable, is there a difference in this variable across the two groups? So the variable is more sophisticated in our analysis, and that's what we call a chi-square test for homogeneity. The other one is a test for independence, and this is kind of like the opposite. If I scroll down and show you this diagram here, this is one population, that's this oval right here, and what are we trying to see? We're trying to see if there's an association between these two variables within this one space, within this one population. So here's a summary table of the subtle differences between these three chi-square tests. So we have a goodness of fit test. And again, all three of these are chi-square tests. That deals with one categorical variable, one population, and it's usually presented with a one-way table of information. The test for homogeneity right there, again, deals with one categorical variable, but we're now analyzing two or more populations, and it's usually presented in a two-way table. And the last one, the test for independence in here, has two variables and only one population right there. So I'll be back with some more basics and differences of these three tests here in a moment.